Yeah.
So, all right. Thank you everyone for coming. My name is Sarah. I'm the Adult Services Librarian here in McFarland. And we feel so honored to have Project Home come for the at least third year in a row to McFarland to show us what they know about different ways of maintaining our houses. And this year we have Brenden Shoemaker coming and talking about furnaces, which is kind of a big thing that all of us should know about. So, yeah. Brenden, thank you so much.
All right, thank you. How's everybody doing tonight? Good. I'm not much of a podium person, so I will be kind of transferring a lot, and I do talk with my hands a lot, so just want to put that out there right away. I'm a bit descriptive with my hands. So, so as it was mentioned, we're here to talk about maintaining and understanding the furnace. So specifically tonight, we're going to be talking about forced air furnaces. We're not going to be talking about boilers or heat pumps. I have other presentations that I do that deal more with some of the other different heating systems. So this one's going to be specifically on a forced air furnace. I can answer any questions that you might have about other types of heating systems, or if you have like oil furnaces and things like that. You know, I can certainly answer most of those questions. So. Everybody turned on their furnace? Is there anybody that has not turned on their furnace yet this year? All right, okay, the same. It usually when it's, you know, one night where you wake up and in the morning it's like 58 degrees in the house and you're like, shouldn't have left that window open maybe. But, and then you gotta kick up the furnace just to like take the chill out of the air. So right now we're definitely in our heating season. So, and it looks like this weekend's gonna get pretty cold. So, you know, having a furnace that's operating properly is going to be paramount. So just a couple of quick things about Project Home. So if you're not familiar with us, we've been around for a long time. So we're what's considered probably be the OGs of air sealing and insulation in Madison. We work in Dane and Greene counties, and we run the low-income weatherization program for the state. We do a lot of home repair programs, and we also have affordable housing with Prairie Crossing, Rodney Shield House. And we also have our Project Home Optimists. So for people that may not qualify for our income programs, our income qualified programs, we can also be used as a contractor, and that's our Optimist program, which is a social enterprise. So when whatever profit that is created from that gets transferred back to the nonprofit, which is our main organization. Yeah, I said 50 plus years in the local community. We do a lot of stuff. I'm a BPI certified building analyst, energy auditor. I've been doing energy audits for 17 years. Been around a long time, so I have a lot of knowledge about heating systems, furnaces, just homes in general. And I've been working in residential and commercial construction for over 25 years. Kari, do you want to talk real quick? You have to come close to me, they said, so yeah.
I just have one slide. So Project Home is partnering with the Dane County Office of Energy and Climate Change. They have a program called the Home Energy Guides program. And basically, they have two organizations where there are individuals who are trained to help people in the community understand what programs are out there for saving energy, saving money, rebates, tax credits, you know, tapping into those programs that are government funded. And so I'm partnering to spread the word about this program, that these people are out there and they can literally work with you one-on-one and help you learn and figure out if you qualify for any of these programs to save yourself money and save money on doing some energy upgrades to some of your appliances at your home. So basically what happens is if you scan the QR code, and there's also a QR code on a pull-up banner over at our table, you put in just your name and contact information, and if you know anyone or want someone that speaks a different language, you can indicate that. They have home energy guides that can speak other languages and help people, they will reach out to you. So right now, the two organizations that have home energy guides trained to help people are the Hmong Institute and the Wisconsin Eco Latinos. So those are the individuals. They're going to be reaching out from those organizations when you get a call back, if you use the QR code and put your information in. And then they take it from there. So it's just a resource that's available for people. Some of these programs and rebates are for individuals with certain income levels, but you know, you may qualify for something. So I just want to share that with you, and it is a resource. So.
All right, thank you, Kari. Okay, so understanding the furnace. So there's a lot of components to a furnace. This one specifically is a high efficiency sealed combustion furnace, and that means that it has two PVC pipes. One goes, or they both go to the outside. One is an intake, fresh air intake, and one is an exhaust. So anytime that we talk about like a sealed combustion furnace, which is anything that's 90% efficiency or higher, it's going to have two PVC pipes that come out of it. Manufacturer specs always say that both of those pipes need to go to the outside. Throughout this presentation, I'm not going to name any contractors or anything like that, but there are some contractors that don't like to do things towards manufacturer spec, and that is generally almost every contractor. So a lot of times what we'll see is the exhaust pipe is to the outside and the intake is just left wide open. The reason that's a problem is then you're just intaking air from the basement, okay, which can be full of dust, it can be full of whatever else, right? And you're putting that directly into your burners, which can cause premature rusting, clogging, things like that. So when it's a sealed combustion furnace, both intake and exhaust should go to the outside so that you're always having fresh air come in. So there's a few different things. So this furnace that we have is built so that you can see a lot of the parts, but I'm going to open it up and I'm just going to kind of point out a few things just so you can see what we're looking at. Now, sometimes the doors come off really easy. They've got clips like this. Sometimes you need to unscrew some things. The most important thing is making sure that if you do open your furnace that you power it down. And a lot of times that's at a switch right on the side. Okay, sometimes it's right at your fuse, because not always just having the thermostat turned off means that the actual unit is powered off. So you actually want to shut the power off here. Typically with the lower panel, when you take the lower panel off, there's a safety switch here. A lot of contractors will stick something in there, they'll put tape over that so that it doesn't pop back out. The reason that we want this to be free, so when that comes out, it completely shuts off the furnace. So it powers it off completely, and that's to keep people from, you know, sticking their hands in here. And you'll see later a little bit more about that, because it is dangerous. So the blower wheel, which is the part on the bottom, the blower motor pushes all the air through the system. That, what we call a squirrel cage, runs at like 500 RPM. So, or more. So putting your hand in there would take your fingers right off. So we want to avoid that as much as possible. So there's a couple of components that I'm showing here. So the burners, so your burner chamber is usually up towards the top. And that's where the actual flame gets injected into the heat exchanger. And I know you can't see it directly from there. But at any point, if you need to ask questions or if you need to come take a look, that's fine. So the heat exchanger, which kind of looks like this, right? It's like a little S curve. This one has two heat exchangers. Because it's a sealed combustion furnace, it's high efficiency. It needs more surface area for the air to blow across. That creates a lot of condensate. And the condensate actually collects and it comes out of these tubes. And it should go into a floor drain, directly into floor drain, not into a utility sink unless you have a condensate pump. But everybody has a little different setup. So Just talking quickly about the heat exchanger. So the furnace itself, when the burners come on and the heat exchanger gets hot, the blower motor comes on, pushes that air across the heat exchanger. And the reason that it's kind of S-curved like this, because more surface area, more potential for heat transfer, okay? And that's what drives the heat through the ductwork and through the house. So those are some of the basic components. I'm going to show you a bunch of different things, but the burners, the heat exchanger, which is behind here, which it is viewable from the side here, and the secondary heat exchanger, and then the blower wheel, which is down here at the bottom, and they usually almost always look the same, kind of same. So thermostats. So thermostats can be super complicated or super easy, right? This is just a pretty standard, like, programmable thermostat. We'd call like a setback thermostat, where you can actually program it at the thermostat to run. These are kind of going away a little bit. People are going more to either having just a regular digital thermostat that's just easy, heat, cool, power, auto and on for the fan, and up and down for the heat or the cool, right? For the temperature change. So these ones can get a little bit complicated, and I find that usually when we put a programmable thermostat in somebody's house, they don't program it anyways. So what I think is a better option is to go to a Wi-Fi enabled smart thermostat. And I have one at my house, and comes with a handy app, okay? This is called a Sensi thermostat. There's Ecobee, there's Nest, there's a lot of different kinds, right? So I can go right to my thermostat, I can make a program and everything right in the app, and it connects to my thermostat, and I can create a geofence, which means that if I'm a certain amount of distance away from the house, it'll cut the furnace down to whatever temperature I set it at. So if it's, if you leave for the day and you don't want to be heating the house because nobody's there, it could drop it down to 60 degrees or whatever you set it at. And then when you come back into that geofence, then it'll ramp back up to whatever temperature you prefer. This is a really nice thing to have. They're easy to install, and you can get them for like really cheap on Focus on Energy. If you go to focusonenergy.com, you can get a Sensi thermostat and Ecobee for relatively cheap. So, and actually, since nobody's at my house, I'm going to turn this down. So.
Does that actually save money when you decrease the thermostat when you're gone?
It does, yeah, absolutely. Because if you think about it, if you're not heating all of that surface in the house, you're giving yourself more opportunity to have use less energy. So even
work harder to get it back up to temperature?
Not really, no. I mean, typically things within the house, because if we talk about surface area a lot, right? You have to warm surface area. The more we're able to warm that, or it doesn't take long to warm most things in a house. So, and it depends where your thermostat is too, right? If the thermostat's on the main level, and maybe not even near the sleeping areas. If it's near somewhere where there's like sunlight, that can affect what the thermostat's able to do. So I always tell people, put a thermostat somewhere where it's going to be closer to a sleeping area, and also somewhere where it's not going to get shaded too much or too much sunlight on it as well. So, but yeah, and if you decrease your thermostat even 5 degrees every night, you can save a significant amount on your energy bills. So, and I do have a really great presentation about that too. So, I did, yes. So then there's the ductwork. So we mentioned this is forced air furnace, right? So we've got ductwork. Right now I've just got the plenum on here. So anything that comes ductwork that comes directly off the top of the furnace, or it can be the bottom of the furnace if it's a downflow furnace, is what we call a plenum. And the plenum is where a lot of the magic happens. So if you have central air conditioning, okay, this is what actually runs your air conditioning. This is called the A coil. And it's just another heat exchanger that runs opposite from the heat exchangers in the furnace. So instead of getting super hot, it gets super cold. So the refrigerant that runs between your outside compressor and the A coil, this gets really, really cold. And then when the air blows across it, you get cold air pushed through the ductwork. It creates a ton of condensate because, as you know, warm, humid air going across a cold surface creates a lot of condensate that drips into a pan like this, and then also comes down through that condensate line to the drain.
I have a question.
Yeah, of course.
How often should you be changing those tubes out? Because I think I have mold in mine. But,
Yeah.
condensation to, like, how often?
So there's no real set thing, but what I would say is if you have a clean and tune done by a contractor, have them replace it at that time. You can take them off and clean them as well. Like a little bit of vinegar solution.
I've bought new ones just
Okay.
to kind of replace, but.
Yeah, that works too. Yeah, I mean, these can get full of crud, right? I mean, it's in a basement, like there's stuff that gets collected in there. It gets wet, it's like lint and all the things from your dryer, it gets clogged in there. If that backs up, it'll shut your thermostat, or shut the furnace off. The furnace has a ton of different like fail safes, pressure switches, temperature switches, things like that, that will tell the main control board like, hey, something's wrong, shut it down, okay? And that's usually when the no heat calls come in, so. And we will get to that, I promise, So the air filters, so we've got a number of different air filters stuck on here. So you can get real complicated with your air filters, and you can get, the big like 5-inch ones that, you have to like put the little fan, like little combs in there. Those do give you the best filter of the air. It's not always necessary, but if you want to have a little bit cleaner air moving between your return and the furnace, that's one way to do that. I never suggest using your furnace to clean the air in your house. That's not what it's for. It's to protect the unit. This is, this is really all you need, is just a 1-inch filter. This collects most of the dust. Should be cleaned every probably 1 or 2 months, depending on how much, if you have a lot of pets, these get clogged up real fast. This is cheap insurance to make sure that your furnace doesn't fail prematurely. And like I said, you can get as complicated as you want. There's 2-inch filters. It really depends on what you have. All of the furnace filters have what's called a MERV rating, and the MERV rating is like the microscopic energy value thing. So the higher the MERV rating, the tighter the weave of the material to trap more things. During COVID, we were always talking about like, we got to have MERV 11 or MERV 13, right? It doesn't really matter that much. Anything that's like MERV 7 or a little bit more is fine. That's all you need. I think it's MERV 14 would be considered a HEPA filter, and that restricts the airflow so much that you can actually damage the furnace. So that's why I tell people don't go to that level. Just keep it at a level that's like MERV 7 to MERV 11. It's really all that's necessary. But main thing with the air filter is that is your insurance. It does make a huge difference for the furnace, whether that you have a clean or dirty filter. The house that I was at today, I'll just kind of give you a quick aside. So I was at a house today and couldn't get the furnace running. First thing I noticed on the control board was that it was giving me an area code. So I looked at what the area code was on the back of the furnace, and it was an airflow issue. So I was like, okay, check the filter. I checked the filter. I mean, it looked like this, maybe even a little bit worse. even had like leaves stuck to it. So it'd probably been there for multiple years. Nobody had ever changed it. The management company for this rental unit, they weren't doing anything. So I took the filter out, reset the furnace, ran it all again. It still didn't come back on. It still didn't fire up, but I was able to look at what the sequence of operations was, which is what we're going to go into next. And the sequence of operations told me where the problem was, which was the gas valve, which is this guy right here. So the gas valve was on. Okay, I've got this one off right now. It doesn't really matter. The gas valve was on, okay, but it wasn't opening. So I took my screwdriver and I tapped it twice, and it came on. Okay, so something got stuck, right? So I saved them a $350 trip charge from an HVAC company to tap something twice with a screwdriver. So if you know the sequence of operations of a furnace, you can figure out exactly what's wrong with it. And that's something that just makes everybody's life a little bit easier. So a couple other like just basic components here. So we talked about the condensate. The inducer motor or inducer fan, what we call the ID motor, you'll hear HVAC guys say this all the time. Your ID motor's shot, okay? That's this one. So this does the inducer motor does two things. It does a purge of the exhaust before the unit comes on, and then it winds back the other way and it draws the fresh air into the burner chamber from the outside or wherever it's coming from. The inducer motor runs a lot, so sometimes these do fail earlier than the rest of the furnace. A lot of times you'll have to do inducer motor replacement at some time during the life of your furnace, and that's actually pretty normal. Main control board is here at the bottom. That's where all the little solenoids and everything are here. This is where we can change the fan speeds. So if the fan is, if you want the fan to run a little bit faster because maybe not cooling everything fast enough or not heating everything fast enough, can change the fan speeds there too. So let's see, some pressure switches, and we'll talk more about pressure switches and like safety switches on these furnaces as well. So this is where your gas comes in. So the gas, where you can turn the gas on and off here. As long as there's gas going to the unit and you have flame, okay, you'll have a furnace that's running. So there's a bunch of different things that you can look at to determine why isn't my furnace running. Okay. Has anybody ever had a no heat issue where you just woke up in the middle of the night or in the morning and you were like, yeah, okay. Yeah, and you're like, what's going on? Like, why is it so cold in the house? Right? It says it's 58 degrees in the house, but you got it set at 65. You go down there and you hear it going, it starts whirring, and you're like, oh, it's working, and then it goes, right? So there's something wrong. So, and that's where the sequence of operations comes in. Whoa, sure. Okay. Question? Yeah.
Question about ductwork before we
Yeah.
When the furnace turns on and off, and the ductwork's kind of expanding and contracting, is there any way to keep the noise down from that?
So, yeah.
In my house where it's really, you can hear it hold up. Yeah. Exactly.
Yeah. It's called oil canning. So oil canning is happening because you don't have a balance between the supply and the return air coming in. Sometimes it's as simple as, you've got a return blocked, like somebody put, piece of furniture against a return, or there's a carpet covering a supply. Any of those things can create that oil canning. So that's the first place I would check. If it continues to happen, if you're like, nope, everything's like completely open, an HVAC contractor could add some supply air to it, and that usually gets rid of the issue. So yeah, we call that oil canning, where it sucks in these like that, and then boom, it expands real fast, right? So that's the issue, is just the pressure. It's a pressure balance thing. So, okay. So, first thing that happens, assuming that the furnace has gas, the gas is on, and your power is on, is your thermostat. You set the thermostat to whatever temperature you want, okay? So this sends a signal to the furnace. It says, I want you to satisfy this heat requirement. The inducer motor, like I said, starts spinning one way. It purges everything from the exhaust, and then it winds back to start drawing in the fresh air from the outside. There's a pressure switch that's directly connected to the inducer motor, that if the inducer motor starts pulling in the cold or the fresh air and it's not able to because maybe, you know, neighborhood kids stuffed a bunch of rocks into your, these are all things that I've seen. So I just like, yeah. Or, you know, or a lot of homes, right, in Madison, the PVC pipes are like this far from the ground and snow gets piled against them, right? Snow's piled against them. Then you've got exhaust that's not able to get out, and you've got intake that you can't get any fresh air. So it creates a seal, and the pressure switch says, whoa, okay, I can't get any air in, shuts everything down, right? And it just kind of like, it'll just keep cycling. It'll just keep cycling to see if it can get any fresh air. Usually it won't, and that's when an error code will pop up. Then the hot surface igniter, which is right next to the burners, will start glowing. It gets really hot. For this furnace, it's what we call a hot surface igniter, a glow bar. It's just a little piece that maybe costs 25 bucks. It just gets really, really hot. And that's what ignites the flames that come when the gas gets pressed into the burners. Some people have on older furnaces would be a pilot light. Okay, so a pilot light would be same. Okay, so that comes on, and there's a amperage switch that's connected to that. So like I said, all of these things have a fail-safe on it. So if you know the sequence of operations, you can figure out exactly where the problem is. So if it says the hot surface igniter, I can't get the right amperage to it, it'll shut it off. Usually it's because over time those hot surface igniters do get broken. They get used so much that they break, right? They might have a little crack in it and you can't get the circuit through it. So that's a quick fix. Again, it's going to be, you know, with a lot of HVAC companies, it's going to be 150 bucks just to get them to come out, right? And then a $25 piece suddenly becomes a $150 piece. So you can buy them on Amazon. And as long as you know your model of your furnace, you can get the right one. So then the gas valve opens. And so this is exactly where I got to today. Hot surface igniter came on. I heard a click, but nothing happened, okay? And that was the flame sensor, which is another pressure switch, realized that, hey, gas valve didn't open, there's no flame, shut it off, right? Recycle. So that's when I knew the gas valve was the problem. So take the screwdriver, bop, bop, 2 times, and then it was fine. So quick fix, right? You know, like I said, I saved them $350 to have somebody come out, because immediately they'd come out and they'd be like, oh, we got to replace the gas valve, right? Which Johnson Control gas valve is like $200, right? Mark it up, it's $500. So we're already like making that quick fix there, right? So gas valve opens, injects pressurized gas, natural gas in this case, could be propane as well, directly into the burners, goes across the hot surface igniter, creates flames. If you've ever looked into your furnace and you'll see the like blue conical flames going directly into the heat exchanger, that's what you want to see. If the flames are suddenly like really like orange and they're kind of like jumping around and things like that, there's a bigger problem. And that's usually with your heat exchanger. So after the gas valve opens, you've got flame going into the burners, and the flame sensor says, hey, we're good. It just keeps heating up that heat exchanger until it gets to a set temperature. And all of this is set on the control board when they install the furnace. When they install it, it's usually at the factory settings, which isn't necessarily what every house needs, right? You slap something in and you're just like, factory settings, we're good. Every house is different, okay? Every house works differently as a system, and every house needs a little bit different changes to their furnace, so at the control board. So the heat exchanger, whatever its set temperature is, usually it's somewhere around 200 degrees. The temperature sensor says, okay, we're good. Now we can kick on the blower motor, and then the blower motor comes on, and that starts blowing the air, which the return air coming back from the house, right? You've got returns around your house. That comes back through. So that would be like, if you imagine this on this side, okay, that's your return air, and that's coming back into the furnace, and then it's getting driven up through your house. So it's a constant cycle of supply and then return air, okay? Oh, one thing I did want to mention. So on every furnace filter, it says airflow, and it has an arrow, okay? The arrow should always go towards the furnace, like this, okay? Because this is where the airflow is happening, like this, okay? It's never going the other way. If you do put it the other way, it's not the end of the world. It's just, it's designed to be set a certain way so that it doesn't create too much static pressure within the actual ductwork. And static pressure can make things, it can make things fail a little bit sooner, but that would take a lot, it would take a lot of stress on the furnace to actually do that. So blower motor comes on, starts blowing it through. There's another pressure switch in here that's the static pressure switch that says, you know, hey, we've got too much restriction, shut it down, right? So that pressure switch specifically would tell the blower motor there's too much of a pressure differential, shut it down. So these are all these sequences, right? The thermostat then, we're going all the way back. So everything starts going, we're all good here. Thermostat says, hey, we got to 68 degrees. That's what I wanted. We're good, okay? And then it'll start to cycle down. The burners will shut down. The blower motor will continue running. I can wait for a little bit. The blower motor will continue running until the heat exchanger gets to the next set temperature, which is its resting set temperature. And then the furnace will shut down, and it'll wait for its next call for heat. Yes?
Quick question, what's actually reading the temp inside the furnace? Does the thermostat have a way of just detecting the temperature within it, or is there like a separate?
There's thermostats actually built into the heat exchanger that wire themselves right back to the control panel, and then the control panel is able to adjust that. So when it gets to its set temperature, blower motor comes on. When the thermos is satisfied, it waits until it gets to that lower temperature, and then it shuts down. So, yeah.
So with the sequence of operations.
Yeah.
So when you went in, you tapped on the fuel switch there. Is there like a scan tool or something you can connect, or do you have to like physically look at each one of these things to see if they're working or not?
So it kind of depends. If it's something that's electrical, you could use a multimeter that would tell you, it's pulling too high of voltage or something like that. For the gas valve, it's really just if you can get it running or not. So, which is why most HVAC companies, if somebody's like, oh, no heat, and they diagnose it that the gas valve's not opening, they'll just replace the gas valve. They'll say, well, I got to replace your gas valve. So, yeah. Yes, I have an answer.
You tapped on the gas valve with a screwdriver,
Yes.
and it suddenly came back on.
Mm-hmm.
What's to say that
Right.
What was going on with the gas valve that it just was stopped doing its thing?
Yeah, so the gas valve has a circular gate valve. So when the gate valve is like this and the gas can't get through it, right? So there's a solenoid here that turns the gate valve. So when it gets its call to open the gas valve, right? It just does one of these so the gas can pass through. So that little solenoid got stuck. And it's actually a pretty common thing. Yeah, yep, exactly. Or, there are what we consider like budget furnaces, right? So, I don't remember, what is this one again? Is this Bryant? York. Okay, yeah. So York is a bargain brand of Bryant, which is why we bought a York for this one. It's almost the same, except a lot of the parts are not as good. So because of that, you can get gas valves that stick, or you can get control boards that don't work correctly, right? There's a lot of different things, right? And an HVAC contractor, when you buy a new furnace, they'll always give you the good, better, best, right? And the best is usually, like the Lennox or the Bryant or the Carrier, the big name brands. Those are their flagship brands, right? But then they'll be like, well, we could also give you a Luxair, or we can give you a York, or we can give you a Payne furnace, right? Those are all what are considered to be more of their bargain brands, right? Sometimes you just need a furnace slapped in, right? You're just like, I don't really care, just chuck a furnace in. I just want to have heat. So, but some people are like, hey, I want all the bells and whistles. I want to be able to see what the static pressure is in my ductwork. I want to see everything that's going on with my furnace at any one time. I'm that guy. So, but I like the technology that is afforded at times, right? So I do have a Lennox furnace at my house, which you'll see here shortly. But to answer your question, I kind of went on a rant there. But to answer your question, it was most likely because the furnace had not been turned on for a while, and it just needed to have that solenoid, just needed to get a little bit of work, and then it was good. So.
I have a question.
Yeah.
How long of a life would you say when you purchase a furnace? I mean, if you maintain it relatively well, and, or if you neglect it, how long would you say it would last?
If it's a good quality furnace and you, yeah, and if you're doing the proper maintenance for it, yeah. So like a clean and tune every few years. If it's a natural gas furnace, natural gas is a very clean burning fuel. Same with propane. Every 1 to 4 years is kind of what we say for those to get a clean and tune done on them. And then they'll check those parts, right? Sometimes, just like with a car, you got to replace a pump, or, in this case, an inducer motor every once in a while, just to keep it running. But until the full failure of the thing where it's becoming so expensive that now it's more expensive to do repairs than it is to buy a new furnace, 15 to 20 years, And again, a good quality air filter that's being changed when it's supposed to be changed makes a huge difference, right? A lot of people neglect these things, and then 10 years, 15 years maybe at the most for ones that are pretty neglected. I've seen very neglected furnaces that have lasted less than 5 years. But those are pretty extreme cases where, the environment that they were in was not suitable for that. So, yeah.
So you would say 15 to 20?
Yeah. Yeah, absolutely. Could be even more. Usually it's the heat exchanger that goes, right? Once the heat exchanger goes, if there's not a warranty on the heat exchanger, then that would be a very expensive repair. Okay, so to finish up the sequence operations, So the gas valve shuts down the gas flow to power down the burners. Blower motor, like I said, it continues to blow the warmed air through the ductwork until it's set temperature, and then it goes into rest mode. Everything is checked, double checked, pressure switches, all the temperature sensors to ensure proper and safe combustion, right? Because we never want to have an issue where there would be like a CO, a carbon monoxide issue, right? And that would usually happen from something being clogged in the exhaust. But there's switches that are fail-safes to make sure that doesn't happen. That doesn't mean that the fail-safe can't also fail at times too, right? Which is why it is good to every once in a while check things and make sure that, you know, when they do a clean and tune, that they're doing specific things to make sure that everything's safe with the furnace. Okay, so maintaining a furnace. So number one thing is if you have an owner's manual, have it handy whenever you're really like looking at your furnace, right? Changing the filter. Like I said, this is a cheap way to, cheap insurance to make sure that you don't have premature failure of the components or the furnace as a whole. Just opening the furnace doors and taking a look. So like I said, make sure that you're shutting off the power, okay? Not just at the thermostat, but at the unit itself, okay? Or even switching off your breaker, just so that something goofy doesn't happen, right? Take a look inside, you know, if it seems like there's a lot of dust. It gets stored in a warehouse, so it's got a lot of dust, right? A lot of dust. You might see rust. You might see water in the cabinets. You might see a lot of spider webs and things like that. Okay, just using like a soft bristled vacuum tool, you know, just very carefully is fine, right? On the cabinet, the floor of the cabinet, around the pieces, especially around the control board. There are a lot of no heat calls that happen because a spider got itself fried on a control board, and it just shuts it down, right? And then you have to replace the control board. So it's stupid stuff like that where it's like, oh man, but you know, suck up the spider webs. What's that? Even like just like the little like cellar spiders, right? Yeah. So take a look at everything. You know, make sure that like your safety switch is working. Make sure that, you know, you don't smell a whole bunch of gas. When you first take off the doors, if it's been running recently, you'll smell gas, right? Don't freak out. That's just normal. It just had some combustion, and you're going to have a little bit of smell of gas. If it continues longer than that, then that might be a problem that maybe you have a gas leak or something in the gas piping. Yeah, charred, melted components. Looking at the burners too, do they have a lot of rust on them? Does it look like the rust is like falling off? If you have a little bit of rust around the rings of the burners, that's okay. It's just when it's like really rusty, that can signal a problem. And usually it's because there's too much moisture getting into the return air or the fresh air intake that comes in. Maybe the...
I have a question.
Yeah.
I think I have a humidifier built in, like an April air or
Yeah.
something.
Yep.
And I think I have a lot of like moisture that drops in.
Yeah.
So, like hard water starts to kind of...
And you're getting like water stains and things like that on your ductwork.
Yeah.
Make sure that the water panel filter itself is getting changed.
I think that's where I failed.
Okay.
I didn't change
Yeah.
that part.
When those dry out, when they dry out, they won't soak any more water, and then you just get this you get a horrible mess. So yeah. Okay. Like I mentioned before with the ductwork, make sure that your vents aren't blocked. This can cause the distribution issues. Like I said, the oil canning, right? Whistling would usually be because the furnace filter is really clogged, and you'll hear an actual like whistle to it. Grinding or squealing noise, which would probably be the inducer motor or the blower motor, is having some issues, and you can usually figure out which one's which, right? When the bigger blower motor comes on, it can be pretty loud, right? And if you're got your head near here, you can usually tell which one it is that's actually making the squealing. A lot of times it comes from this inducer motor. That's where we see a lot of like the squealing, and that's just because the bearings are starting to go, and it's probably time for a new ID motor. Burning smell, that's probably pretty bad. So, delayed ignition or a loud boom upon ignition, or if you're watching the sequence of operations happen and you see the like flame kind of like blow back out of the burner chamber, that's most likely a failed heat exchanger or clogged heat exchanger. That might happen. So looking for all of those things is good. Smelling for natural gas, propane. They've all got the rotten egg smell added to them so that you can smell that. We test for gas leaks on every furnace that we touch. So I check all of the gas lines to make sure that we don't have gas leaks. I will tell you this, that I'm actually surprised when I don't find gas leaks at a house. So if you do smell, a little bit of gas in your house every once in a while, it's fairly normal, is what I'm trying to say. So I find that if I don't find one or two gas leaks, and when we say gas leaks, I don't mean like the gas is just like spraying out, right? These are like microscopic, tiny things, right? All of these joints have pipe dope put in them, and if you've got an older house, that pipe dope has probably been in there for decades, and it has a half-life to it, and it starts to dry out, starts to crumble, and sometimes the little pinholes happen, right? So I'll be testing, around a joint, and it'll, and then I take some bubble solution, I put some bubble solution on there, some soap on there, and it starts to bubble, and then I know there's a gas leak there. It's not necessarily a dangerous thing. It's more of you're losing natural gas here that you want going here. So that's the bigger issue. Sometimes I do run into gas leaks that I'm like, well, we got to get this repaired today. But that's pretty rare.
How would you fix that? Do you have to take the pipe apart?
Yeah, a plumber does that. So we have a plumber on staff that whenever we find gas leaks, even if we're not working on the furnace as part of our projects, he'll come in and do just takes it apart, new pipe dope, screws it back together, checks everything, and then goes on his way. So when you do have an HVAC contractor do like a clean and tune, ask them to do that, right? Ask them to check for gas leaks. Find gas leaks, fix them. I'll get to that shortly, yeah. Other thing is carbon monoxide detectors. So you should have carbon monoxide detectors in your house if you've got a combusting appliance, whether it's sealed combustion or going into a chimney. You want to have carbon monoxide detectors, alarms, at least one on each level of your home, and usually one near a sleeping area. You can buy ambient carbon monoxide detectors like this. They're not terribly expensive. This is a professional one. It's about $200. You can find ones for significantly lower. If you're ever wondering, do I have a carbon monoxide issue in my house? Can be very dangerous, obviously. Carbon monoxide is not something that you want in your air. So if you ever feel like you might have some kind of a carbon monoxide issue, HVAC contractor, you can buy one, or you can have them check the ambient air for carbon monoxide. Okay.
Is that oil canning detrimental to the furnace, or is the worst that comes from that the noise?
Mostly the noise, but higher static pressure in the ductwork can put a lot of stress on the blower motor. So, you know, if it's significant, you know, if you're getting that like big boom, I would probably have someone take a look at it, see if they need. Sometimes they just they can check to change the blower speed. Maybe the blower speed is too high when it comes on, and that's creating the issue. Maybe you just need more returns added, right? If it's an older house, it'll probably just have low returns. You know, they would put in high returns as well to work through the joist cavity. Okay, so clean and tune. So clean and tune is what should be a comprehensive evaluation of the furnace itself. So that means that they're not just cleaning it up, you know, doing the vacuuming, making sure everything is good. They're checking the amperage of all of the electrical components. They're pulling the burners out. They're cleaning off the burners. They're making sure everything's aligned. Changing the filters, checking the distribution, make sure that there's not a big difference between the supply and the return. That's what they should be doing. Now, most HVAC contractors won't do any of that. They'll you know, maybe clean off some of the electrical components, vacuum it out, charge you $250 and see you next year. If you want it done right, so schedule it for, this is talking about natural gas, also for propane. If you have an oil furnace, every year get your nozzles changed. 2 to 4 years for natural gas, and cost, he's got 220, so this is a little bit of an older slide. It probably is gonna be more like $300 to $400 for a proper clean and tune, right? You'll sometimes see like, you know, you'll get the flyer that's like $100 clean and tune. They're not gonna do jack, okay? So if you want a real clean and tune, tell them what you want. And you know, you want the furnace tested. So they should be having a furnace analyzer and actually testing what's in your exhaust, right? What's the efficiency? What's the carbon monoxide? How much oxygen is in there? That can tell you a lot about where your furnace is at as far as its life goes. So ask for that furnace testing report and ask them to explain what they're seeing to you. Like I said, so this was, you know, if you set it at factory settings and the house is not, the house needs to be, the settings put differently, right? But they just slapped it in and they were just like, you know, we're good. See you in a couple of years for your clean and tune.
Do you have a lot of people watch you when you're working to see what you're doing?
Oh, yeah.
Okay.
Yeah.
I don't know if that's something that people do, or they just kind of leave
They
it
do.
here.
Yeah, like sometimes people are just, you know, curious about it. And sometimes people just want to ask a lot of questions. And, you know, it's fine with me because, I mean, it's their house and like I want people to be empowered with their homes, you know, and be able to, you know, if they do have an issue, be like, okay, you know, here's a way to fix the issue. So, making sure that combustion's within manufacturer specs. Do they need to adjust the gas pressure for more efficient combustion? Maybe it's a little bit low and they need to adjust things just to get the efficiency a little bit better. You know, this could be something like 93% efficiency to 95% efficiency. That 2% over an entire heating season will save you a lot of money. You know, and every furnace has what's the AFUE, right? You see that a lot. Annual fuel utilization efficiency. So this one I think is a 95% efficient. That doesn't mean that it's actually always going to be 95% efficient. That's why I have to check it with this, right? The furnace analyzer is going to tell me what's the SSE, the steady state efficiency, and that's the actual efficiency of the unit. The AFUE is what the efficiency was at the factory, and that doesn't translate always to in your home. Carbon monoxide reading. And then another one that gets overlooked, and this is a big one, is temp rise. So temperature rise. what's the difference in the temperature between my supply air and my return air? Okay. Once this hits a steady state, I should know that this is maybe 125, right, at the supply. And this is maybe 70 degrees here. So then you just subtract the return from the supply temperature. And on the back of the furnace, this one's cut out, but so you see where it says air temperature rise? It'll be a range. 30 to 60 degrees is pretty common. So you want that to be within that specification. I run into new furnaces all the time that they didn't even do a temp rise on. You know, and the manufacturer requires the installers to do all of these tests before they leave, but they don't do it, okay? And this is one of the things I try to tell people all the time. Empower yourself to tell a contractor, this is what I want, this is how you're gonna do it, this is how much I'm gonna pay you, right? And if you're paying a bunch of money for all the bells and whistles on a furnace, you absolutely should be getting all of the installer requirements done. So something as simple as this, where you just have, you know, a $5 thermometer, you know, telling you what the temperature rise is. That can tell you a lot about what the furnace is doing. If the temperature rise is too hot, you're putting a lot of stress on your heat exchanger. If it's too low, you're probably not getting the efficiency of the heating. So just that alone can tell you quite a bit. All right. As far as HVAC companies go, there are good ones. Look at reviews. You know, reviews can tell you a lot. Google reviews can tell you a lot about a company. If, you know, they're 4.8, 4.9, 5 stars with, you know, 70 plus reviews, they're probably pretty good. You know, if you get ones that are lower, just be aware of that. If they're sending you flyers for a $100 clean and tune, they're maybe not the best. It's maybe not the best company. This is all I'm trying to say. So I leave that up to everybody individually, but I have a furnace contractor that I use, and like I said, I'm not gonna name any names, but that I use. But they're very good, and the owner of the company actually does the work on my furnace, so he knows exactly what I want and require with every time that I pay him, you know, for whatever the clean and tune is done. So, all right, no heat situation. If you wake up in the morning and it's really cold in the house and you hear the furnace either running or not running, and just kind of like going through its cycle, follow all of those sequence of operations, and you can usually figure out what's happening. The other way to figure out what's happening is there's an LED light on your control panel, and there's usually a little like viewing port. So it's usually something like this. And there'll be a little blinking light, blue, red, whatever it is, right? Or it'll have like numbers, or it'll have a combination of things, right? And that'll tell you, you know, is it heating? And you can find, using your manual, you can figure out what it's telling you, what the furnace is telling you. So if it's, you know, HT2, just as an example, it means it's heating in the second stage. If it says, like the one today, it was AFI, I think, airflow issue. So I knew that there was an airflow issue. So that was why I went directly to the filter. So that sometimes it's like that. Sometimes it's a blinking lights. So it's like Morse code, right? It'll be like long, short, short, or, you know, like something like that, right? And you can look at your manual. Sometimes that's right on the bottom panel. It'll have like a little tear out section, and that'll tell you all of the codes. So it'll tell you what its Morse code is saying, and you know, why it's having an SOS at that moment. So just another way to be able to figure out what the issue is. because it might be something as silly as you've got too much snow on your intake, right? Just got to shovel the snow away, clear that out a little bit, and then you've got heat again. Or ice buildup on the exhaust, and right, just got to shake the ice off of it, and things should be running again. So, making sure that start at your thermostat and just kind of like work your way down from there, right? Make sure that you didn't accidentally set the thermostat the wrong way, and that can sometimes be the start of it. So, we mostly talked about all of these, to be honest. So, does anybody have any questions at this point? Because I'm going to show you a little video that's going to give you like a little bit more information on this. Yeah.
Imagine you hire someone to tune up your furnace. Why don't you do these?
The doctor doesn't treat his own family.
Right, yeah. It's more so because I don't have the experience that they have with like pulling the burners out, cleaning the burners, and like making sure things are aligned. I'm more of the like physician's assistant that comes in and like, and figures out the slog work, right? And like, okay, this furnace has a heat exchanger issue or something like that, But then I'm not a licensed HVAC tech, so I can't. So I wouldn't work on anybody else's furnace, If I can diagnose basic stuff, great. If it's something much bigger than that, then I got to call in the big guns. So yeah. I will do things like vacuuming it out, cleaning off electrical components, stuff like that. Checking for gas leaks, stuff like that. I'll do all the time, every year. But right, yeah. But I only have my contractor come in every 3 years because I don't have a dirty furnace or anything like that. But he does a great job, and you'll actually see, because I am getting a clean and tune done this year. So, all right. When you're having a no heat issue at your home, first place to start is your thermostat. Make sure that your thermostat is working and that you're able to change it from off to heat. The fan should always be in an auto position. Check to see if a schedule is on. Depending on your thermostat, you may need to change the batteries as well. We're going to turn this one up to 70 degrees, and let's go take a look. You'll hear a click momentarily. It says it's heating. So we're going to go take a look, show a few other components of this furnace. Another thing you'll want to look at is the PVC pipes on the outside. Assuming you have a sealed combustion furnace, you have one that's an intake and one that's an exhaust. You want to make sure that there's not intake,
snow blocking these,
exhaust,
or that they're not like iced up. If you have snow around it, dig it out. If they have like excessive amount of ice on them, break that free and just make sure that everything is clear, because that can trip off a pressure switch. Also check your main breaker. Make sure that you've got power to everything. Wherever it says furnace, you want to make sure that's in an on position and that it's not currently tripped. Take a look at your fuses, make sure everything looks okay. If you have older screw-in fuses, you may need to change one. Ensure that your furnace is in an on position. You should also check your furnace filter to make sure that it's not excessively clogged with debris or dirt that's causing the unit to power down. So this unit is a high efficiency furnace. It's got two PVC pipes, one goes to the outside, or both go to the outside. One's for intake, one's for exhaust. This means it also has two heat exchangers, which means it creates condensate, and ensure that there is water coming out and going into a floor drain. A few things to check real quick is, one, you want to make sure that there's actually a flame
inside. There's your burner chamber. You can see flame in there. The flames are nice and blue going into the heat exchanger, so I know we're good there. Yeah, I guess so. So one thing I did want to point out with that, with my furnace. So I bought my house in 2018, and so there's like a big rust spot on the, like right here on the bottom of the floor of the top cabinet. So I wanted to address that real quick so that somebody would be like, why does that guy have so much rust in his furnace, right? So when I bought the house, the furnace was 3 years old or something like that. It was installed by a company that has bright yellow vans, and is just down the road from here. They installed this furnace, and they didn't connect a manifold for the exhaust correctly. So when I did my inspection of the furnace, because I did my own home inspection too, I took off that front panel and there was water everywhere. And I was like, well, that's not good. So I couldn't figure it. I dried it up and everything like that, but it wasn't, at the time, it's not my house, so I can't fix it. So we told the owner at the time, get it fixed. And they were like, oh yeah, no problem. And the inducer motor there was a little bit of squealing in the inducer motor, so I knew there was some things that needed to be worked on. So fast forward, we come to the walkthrough the day before the closing, and I opened the furnace cabinet, and splash, splash, splash. Water's all still there. So we're like, hey, like, this has got to get fixed today. And the tech that worked on it, that did all the work, said there was no water. So I took a video of me splashing my hand in the water, and I was like, are you really calling me a liar, right? I've been working on furnaces for a decade plus, and like, I think I know what condensate looks like, right? So the issue was that the manifold, which is like this piece here, which is usually a rubber piece, was not connected correctly at the time of installation. And so when the hot air is getting let out from the exhaust, there's condensate in that air, right? Because the warm air hits cool spots, condensates, right? And that drips down, that's supposed to go out through the condensate drain. Well, because there was a gap there, it was just pouring back into the furnace cabinet. So I said, you know what, forget it. I've got a contractor that I'm gonna call in, and he came in and he was like, this is the issue. He fixed it, he dried everything up, and he was like, oh, and they also forgot to like remove the shipping bolt from the blower motor, and stuff that could have like been a catastrophic failure. So I'm not saying that company with the little yellow trucks is bad, but in that case, they were quite negligent. So long story short, that's why that rust spot is still there. So the flames are nice and blue going into the heat exchanger, so I know we're good there. We're also looking for other things like water. This furnace has obviously had a water issue in the past. It seems to be cleared up. Here's your furnace tag. This is what's going to show you manufacturer, model numbers, temporize. A lot of the manufacturer stuff is on here. Okay. We also have a condensate trap on the outside. This is where all of the water, all the condensate that's created from the combustion is pooling into here, and that goes down into that drain. Now I'm going to shut off this furnace, and I do have a handy dandy little app, so I can actually shut this furnace off here. Shut that to off. Could also shut it down at the switch, which I'll do in a moment, because I'm going to take that bottom panel off. So the furnace is off. I shut it off at the safety switch too, or the main switch here. There's a safety switch for the bottom panel, when this is depressed, that'll allow the furnace to function. When it's tripped like that, it'll shut everything down. That's mostly to keep people from, accidentally sticking their hands in here. This blower wheel moves pretty quick, and it's made of metal, and it'll take your fingers right off. Here's our main control panel. And further in, we can see our furnace filter right there, and the blower wheel. Try to get a better view. So all of those parts should be cleaned during a clean and tune. This one looks like it probably could use a clean and tune probably in the next year or so. Furnace filters here. Gas lines are here. Always make sure that the gas is turned to the on position, and also at your gas valve, it should say on. If any of those are off, you need to get those put back on. So I've got the furnace turned back on. A few other things that you're looking for. You should do a visual inspection every year just to check the parts and things. Checking to see if there's any like leaking, things like that. A lot of this was some old leaking. The stains were already there. There's no current water leaking from the AC there, so that's okay. I'm actually going to be starting my furnace analyzer. So I've got my furnace analyzer in the exhaust pipe, and that's going to be actually testing for the flue gases. So it's seeing what the combustion is. That'll tell me the efficiency, how much carbon monoxide is prevalent, and a few other things too. I'm also checking the temperature. So these are the temperature test lights. That one's specifically for the return, and higher up we've got one for the supply. So these are just like $5 to $10 thermometers. You don't even need two, you can just have one. You just take those numbers and subtract the return from the supply temperature, and that'll give you your temperature rise, which there will be the temperature rise on the manufacturer's label on the inside of the furnace. So it's currently combustion happening. The heat exchanger is getting warm. It's going to start blowing through momentarily here. So currently testing the exhaust PVC here. I've been listening for the sequence of operations from this unit. Everything seems to be going great so far. I've got my furnace analyzer going. So this is something that you should ask your repair techs to do. Shut that light off real quick so you can see that better. Doing the furnace analyzer so you can see, how much carbon monoxide. So this is carbon monoxide. This is your efficiency of the furnace. So we're over 95% at the moment. This is all pretty good. The temperature of the flue gases should be less than like 100 degrees. Anything over like 125 degrees could potentially melt the PVC. So you want to you make sure that's low enough. So ask your techs to do this for you, and leave a printout of the sheet, or at least give you the numbers. Sometimes they'll write them down on the warranty paperwork. They'll write down the numbers for the efficiency and the carbon monoxide and all that too. So and let's take a look at our temp rise. So we're at about 116 degrees. So you would typically want this to settle. So once that settles at a certain spot, whether that's 125 degrees or whatever it is, and then just subtract that from whatever the number on the temperature of the return. So we'll take a look at that in a minute. So it looks like we've hit a steady state. We're at about 128 degrees. I usually round up. 128 degrees minus 68 degrees, so about that'd be about 60. So you'll check then the manufacturer's label to make sure that was within the specs. It's a little bit on the high end for this unit. but it's not terrible. Typically, you want to be a little bit on the higher end, but that's also something that the tech could adjust the furnace to get that temp rise down a little bit, whether it's having more air blow across the heat exchanger or some other adjustments to the gas pressure. All right. So usually your furnace manual should be, here or stuffed in here. If you don't have a manual, I suggest going online and printing one off. It's worth it to have it, in the moment that, suddenly you have no heat issue, and, just looking at the manual will tell you what that error code that it's giving you, right? The SOS. I mentioned the furnace tag too, right? So air temperature rise here. It's such a simple thing to do, and I don't know why, people skip this, but that can tell you a lot, right? As far as like other things like gas pressure, like in inches of water column, most people don't need to know that. That would be something that installer or repair tech would need to know. So if they're checking that pressure. And then, like I said, your manual here is important to have. All right. So we mentioned the heat exchangers and kind of like the more catastrophic failures. So there's your primary heat exchanger, and if you have a high efficiency furnace, you've got a secondary heat exchanger, right? So this is exaggerated quite a bit. I mean, this is really bad. But if you've got holes in the heat exchanger, that's allowing combustion gas to potentially get into the air that's being circulating through your house, which can cause a carbon monoxide issue. That's what we consider a catastrophic failure, right? Where now you've got a couple choices, right? If the furnace is so old that maybe there's other repairs that need to be done, you're talking like a couple $1,000s, it's probably better just to buy a new furnace at that point. If it's under warranty, sometimes there's like a 15 to 20 year warranty on heat exchangers. On the material, right, the actual heat exchanger will be under warranty. The labor to put it in will not be. So just understand that, right? Same thing with the secondary heat exchanger. This one was just covered in like dog hair and stuff like that because they never changed their furnace filter. Like I said, that was probably maybe like 10 years worth of crap that got stuck all over that, right? And it's really difficult to clean that all off. You have to pull everything out. It's very labor intensive, and it can be very expensive. So if we get to this point, there are sometimes choices to, if it's a newer furnace, nothing else needs to be done on it. There's a warranty on the materials. You can make the choice at that point. Do I want to invest in a new furnace, or do I want to invest in having it repaired? But usually this won't be like big cracks like this. It'll be, the metal will just have like separated a little bit in certain spots. If you're having a clean and tune done and they say, oh, your heat exchanger is cracked, ask for them to confirm that with pictures. Because again, I've met contractors who will just say, heat exchanger is cracked. And it's not necessarily true, right? They may just be making an assumption. And so then people are like, well, I got to spend all this money then for a new furnace, right? Well, that's what they want. So ask for confirmation via picture, or have them show you visually that there's where the heat exchanger is cracked, right? And they can get into the plenum, right? You can cut out a piece of here and be able to look down on the heat exchanger, and they can verify for that. Like, yeah, look right here, there's a crack. Okay. Don't just take their word for it. And this is what I always tell people: be empowered to ask these questions, right? Don't just take their word for it all the time, because contractors do want more money. So if you go with the way of a new furnace, so most new furnaces are 95% efficiency, 96, sometimes 97% efficiency. That should be verified at installation with one of these. Am I actually getting the efficiency that I'm paying for? Have them verify that. 3 quotes is the minimum. You know, we always say like get 3 quotes, right? 3 quotes should always be the minimum. Sometimes you get 5 quotes, right? Sometimes more, depending on, you know, if there's a huge change, you know, one company's saying like, we'll put one in for $4,000, one company's will put it in for $7,000, right? That's a pretty big range. You know, you might want to get more options there. Having them perform a heat loss calculation, sizing for the house. So heat loss and cooling loads, they have to make sure that they're setting up the furnace for your house, right? Your house is not the factory. Your house is your house. And it works as a system, and they need to make sure that they're setting it up properly for your house, which means running a heat loss calc, also known as a manual J, every time that they do a furnace install. It has to be done. And that requires them, you know, looking at what kind of insulation you have, kind of windows you have, the size of the house. All of that gets taken into account and gets put into their software that tells them how to size the furnace properly. There is times where people have a oversized furnace for their house, right? Maybe like just 60,000 BTU furnace. So pretty big furnace, right? For a smaller house, and maybe sometime in the past, they did weatherization at the house, and they got, you know, it's well insulated now. They've got new windows, and they don't need another 60,000 BTU furnace. They probably would need like 40,000 BTU furnace. So if they don't size it properly, then, you know, you've got other issues where you can put a ton of strain on the heat exchanger or the blower motor. All the components can fail then. So get a copy of the permit from the building inspection department, and the city inspector may also show up to check the installations. Madison, they almost always do. Other municipalities, hit or miss. Fitchburg definitely will. And then also, like I said, get to know what your indicator light, your LED indicator light, what is normal, and you know, make sure that you have somewhere where you can see what the diagnostic codes are in case you have a no heat issue. Okay. That's the end of the presentation. It doesn't need to be the end of our time together. If you have other questions, I did want to circle back one thing real quick on that oversizing furnaces, right? Oversizing and undersizing furnaces is a big no-no, but it's something that happens a lot in the HVAC industry. So I mentioned, you know, having too big of a furnace in too small of a house, right? So what happens in that case is you've got all of this combustion happening, right? And all of this here in the burners, there's a ton of combustion that happens. And so you've got all of this heat that needs to be transferred. Well, you're just blowing it into a small space, and it's just too much. And all it does is it just puts a ton of strain on the heat exchangers. The heat exchangers will get really, really hot. And sometimes at that point, it'll shut down because the temperature thermometer that's in the heat exchangers will say, whoa, too much heat, okay? And it's what we call running on limit. It's just a fancy term that we use, but it means that there's too much heat, right? First rule of thermodynamics, right? Heat cannot be created nor destroyed, right? So when you move that energy, when you transfer that energy, a lot of energy into a small space, it's going to heat up that space too much. And in that case, you can have component failures and you can have damage to the furnace. So this is why they need to size the furnace correctly. So they have to run their software, and they have to run it accurately too, right? When I run an energy audit on somebody's home, I take all of the components of their house and I accurately put in what's actually there so that it can tell me, you know, the software, the algorithm can tell me what's actually happening with the house. So Same thing with the furnace. Don't let people skip that. So if you're in the possibly going to be replacing your furnace anytime soon, okay, use all of this information and, like I said, empower yourself to be able to tell the contractor, like, this is what I want, right? When they sit down with you at your table to be like, here's good, best, better, okay, and you start asking questions about like temporize and like gas pressure and things like that, they're going to be like, whoa, these guys know a lot, right? And they're expecting, you know, Johnny homeowner to just be like, you know, oh yeah, I'll just take the middle. Everybody takes the middle, right? I'll just take the better, you know. But as soon as you start asking like good questions, now they'll be like, oh, you want to know more about this, right? And now they've got to work a little harder to sell you. And they've also got to work a little harder on the installation end to make sure that they're doing it the way that you want it to be done, okay? And that is really important. And I do always want homeowners to know that there are contractors that can be real POSs. And you know, you have to ask the hard questions or you're not going to get the right service. Okay. This is our contact info. As Kari mentioned, you know, we're part of that Home Energy Guides, right? So if you contact us through our website with questions, somebody will get back to you. We do like to talk to homeowners around the area and help people out as much as we can, whether it's questions about insulation or furnaces, heating, cooling, right? Solar. I'm also a PV solar associate, so I've got a lot of information, and we can really help you out with that. So, anybody have any like kind of outstanding questions right now? Yeah.
We did some cement work around our house, Jack's been in the driveway. Now we have dust in our house. Do you think something got covered up or blocked?
It's possible.
Yeah.
How would I find out?
Is your intake pipe for your furnace anywhere near there? Okay.
Possibly. How do I know?
Check that. So you'd see the PVC, like in the video, or the PVC coming out of the side of the house there. If that's somewhere near there, that silicon dust from the like cement work can certainly get pulled into the furnace. So you might want to open your furnace cabinet and see like what it's looking like in there too. Yeah.
Is there any circumstance that you run your furnace on instead of auto?
That one's a better one for my for my optimizing home performance. But I will say there's no reason to circulate the air through your house unless there's something, something goofy, maybe like smoke alarms are going off because you burned a pizza or something like that. You might use that then to kind of circulate the air through your house. But really just keeping it on auto is all that's necessary. Newer furnaces have a lot of electronic components that are built into the blower motor that will tell the motor how much to run at what speed it wants to run at a certain part of the heating. So it's better to just leave it on auto and let the furnace decide that. Yeah.
Just going back to the troubleshooting, I mentioned that there was a circumstance where my furnace just shut off, cold January winter night.
Mm-hmm.
Actually had that happen a couple times, but after having the tech over to do a service and clean, got the idea that there might have been some type of draft, updraft, that had caused the furnace to shut off. It was one of the reasons that they came up with, because there was really nothing, that
Like an updraft, the
winds through the intake, just
Okay.
the wind kind of blowing and kind of triggering the furnace to shut off.
Sure.
And I just kind of thought that one was rather interesting. I hadn't heard of it, so.
Yeah. I mean, if it's if the intake PVC pipe's on the leeward side of the house and you've got wind blowing across that, there's that Venturi effect that happens, right? And that slows down this air. That could trip pressure switch. I could see that happening. I think it would be very rare. If it was happening a lot, I would tell them to pitch the PVC so that, add some elbows or something like that so it pointed a different direction. So, yeah.
Appreciate that.
Yeah.
Yeah,
Go ahead.
a couple things. So on the cleaner too, they actually take the burners out.
They should.
Those.
Yep.
Is that something that we can do at home? I mean, that's
I wouldn't. Yeah, I wouldn't. Even I don't want to do that. Yeah. I mean, the burner chamber, the blower motor, like to clean those fins in the blower motor, like all of that should be part of that service. And if you pay for that service, then you should get that service, right? So, because those are big things. Those are big components, and you know, a little, you know, what do they always say? The ounce of prevention is pound of cure. So, yeah.
One other thing, so not related to the furnace necessarily, but we were talking about the furnace being oversized and that's a bad thing, it's a bad combination. So I've got an air conditioner that the previous owner put in this huge in my house. And he said he bought the biggest, fattest air conditioner fine. You know, it's 25 years old, it's a train, and it's still going, so I don't want to replace it if I have to. Is that also, I mean, obviously it's probably requiring more energy than it should for
Yes.
the house.
Yep.
Right?
Yep.
And it still
Cooling
runs all
loads.
the time.
Yeah.
So
Cooling load is the same as a heat load, right? If you're transferring too much energy into a small space. Yeah, and that's sometimes what happens is people are like, well, I want the biggest, and the contractors will sell it to them. And like, why? What are you doing? Yeah, so it's probably not as paramount with cooling as it is for heating. Heating definitely, there's a lot more that can fail. Air conditioning, refrigerant lines, it's
it's gonna run at that temperature, but it's
Yeah.
just taking a lot more energy than
right. The efficiency is probably, whatever your SEER rating is probably like completely stinks. Yeah, yeah, yeah.
Is the plane fan function ever useful for anything?
Say that again?
Not heating, not cooling, the plane just fan function?
Or just turning the fan
Yeah,
on.
what would that be useful for? Anything?
I mean, there are people that think that, having it on and like circulating the air through their house is, actually like changing the comfort of the house. And, I would challenge those people to actually like try it 3 days with it on, try it 3 days without it on, see if it makes a difference. Sometimes a placebo effect. So, and you're just using energy to run something that really probably doesn't need to be running. So,
Does that use the same amount of energy as heating and cooling? Just the fan?
well, it uses more electricity. So yeah, you're just sucking up electricity. And those fans do, for that to start running, there is a burst of like amperage. So you do get quite a bit of electrical load right away. So it does cost more money to run the fan. And it's not always necessary.
Is it pulling in outside air or just?
It's just recirculating from your return and supply.
And you mentioned getting 3 quotes if you're going to replace your furnace.
Yeah.
Do the people come to your home or they do it over the phone?
They should be coming to your house. Yes, they should be coming to your house. They should be looking at what you currently have and being able to like sit down and show you, here's what we suggest. And that's when you ask them the hard questions. Yeah. And tell them I talked to Brenden at Project Home, and they'll be like, they'll get in their car and drive away. So yeah.
I remember them talking about 2 stages.
Yes.
What is that?
So 2 stages. So there's it's the amount of energy that's actually being combusted in the burner chamber. So in a single stage, maybe only one of the burners will be going, because maybe the heating, the thermostat is just asking for like 1 degree change. So it'll start out at like a lower combustion and just less energy used. But if you bumped it up to like 6, 7 degrees or something like that, it would go into its like high fire mode, which then all the burners are going at the same time, and the blower motor is going at its full speed. So it's just a way for the furnace to decide, do I need to actually use all of my energy, or can I just use a smaller amount of energy to raise the temperature, 1 degree, something like that. Yeah. Yeah.
Sort of an older AC, one that gets replaced, any reason to go to a heat pump for that, or just stick with a gas furnace and an AC unit?
It depends. So if you already have everything set up for central air is very efficient. It requires a little bit more energy than a heat pump does, because you have an outdoor unit, indoor unit, right? So there is a little bit more of an electrical load there, but it tends to be very very efficient, modern air conditioning. Usually where we would see heat pump being used is in specifically for air conditioning would be somebody that has like a boiler or some other type of furnace that doesn't have ductwork and they can't install central air. I mean, they could, but they'd have to put all new ductwork in the house. And if that's not an option, then people will use heat pump on the outside to for cooling, but it can also be used in shoulder months for heating as well. So it's going to be considerably more expensive to go with heat pumps because you'll probably have to have, depending on the size of the house, probably two outdoor units and maybe 4 cassette heads on the inside.
Previously, I just had the heat pump that was just like the AC unit, but it was just tied into the furnace. So it was
Oh, okay. It was a hybrid type.
not any split at all.
Okay. Yep. If it's tied directly in like a hybrid unit like that, I would go for it again. I love heat pumps. I like the idea that I could run a cold climate air source heat pump in shoulder months instead of turning on the furnace. Like right now, it'd be perfect for heat pumps. So, yeah.
Thanks, Brenden.
Yeah, of course. Thank you, guys. Yeah. If anybody has to leave, no problem. I'll just answer whatever questions are left over. So, yeah.
My question is just in the very beginning, you mentioned with the control board, you can change the speed of the blow motor on.
Yeah.
So I noticed that our AC runs at a very high speed, but our heating, it's a very mild kind of blowing through the vents.
Right.
Is that an easy thing to change on the control board? Or
It
is that
can
something
be.
we should talk to, HVAC guy?
Yeah, I mean, if you don't want to change it without knowing why it's being changed, right? So if the heat exchanger gets too hot, you want to have a higher pressure of air going across it to strip that energy.
Our house gets comfortable. I was just curious. Sometimes it's nice to
Yeah.
have more air blowing through. It just feels nicer, but
Yeah.
if it's fine as is, I should probably just leave it.
If it feels fine, I would leave it. Next time you have a clean and tune, maybe bring that up and, see hey, could a little bit of change there be good, right? Because typically for heating, you want to have a little bit faster. You'll be medium high for the heating and medium low or low for the cooling, because you want that to you want the air to go when it's cooling a little bit slower over this heat exchanger, so that you can really strip the humidity out of it.
Yeah, I just noticed by the vents when our AC would be gone, you'd really feeling the air coming through, but the heating is just very lightly coming out of the vents.
Yeah. Something to definitely ask. I wouldn't change it unless you know why you're changing it. So, yeah.
Are you supposed to do the air conditioner unit outside the house in the winter time? Are you supposed to put a cover on it?
Don't put a cover on it. It becomes a rodent nest. What's that?
You said don't cover the air?
Don't cover it. So,
Cover it this weekend.
so if you put a full thing over it, you're just going to invite mice and stuff to find their way in there, and then they start chewing on things. If you're going to cover it, just cover the top. Just get a piece of plywood or something like that and a brick, and just put that on the top. That's fine. I mean, those units, it's not necessary. Those units are manufactured to be able to handle all of the stresses of, our climate. So, yeah.
So thank you.
Yeah, you're welcome.
Thank you
Yeah.
so much, Brenden.
Yeah, thank you everybody for coming. Appreciate it.